distributions. Binomial distributions are just a special case of probability distributions. It is a way of shortcutting a lot of the work that we have to do. I'm going to show you with an example of coin tossing in a second, but let's talk about what a binomial distribution is. It's still probability. It's still a probability distribution. So the rules for probabilities are still going to hold. In addition to that, we have some special rules that make it a binomial distribution, and we call that bins. And bins means that the B stands for that it can only be binomial. Bi means two. It can only have two outcomes, or something that can be reduced to two outcomes. So, and we call these two outcomes success and failure, basically what you want and what you don't want. So the probability of it and then its complement. An example of binomial, easy example, is coin tossing, heads or tails. Another example of binomial is something like free throws in basketball, because you can either make it or you miss. There must be a fixed number of trials, that's the N. The fixed number of trials means that I'm going to toss the coin a certain number of times, 3 times, 5 times, 10 times, 500 times. I'm going to shoot a free throw 10 times, 20 times, 500 times. The outcomes of each trial must be independent of each other. That's your I. The independent means that you can't do card pulling where you don't replace. You must always replace the card. So an example of binomial would be pulling an ace out of a deck of cards. I know that there are more than 2 outcomes, but you can reduce it so that you either get an ace or you don't get an ace. So success or failure. Okay, here comes the golden retriever. She thinks I'm talking to her when I make videos. I should actually put a picture of her up sometime. Anyway, okay, so the independent part of it means that if you want to do cards and you do ace and no ace, you're going to have to replace and shuffle so that each trial stays independent. If you do it where you're not replacing, then it's no longer independent. And then the last one is the S. The probability of success must remain the same. These two kind of go together. You can kind of lump them together. You can't change the probability. So you have to, like, if you're card pulling, you have to put the card back so the probability of an ace, which is 4 out of 52, stays the same each and every time. Okay, so if you have those 4 things, I call them bins. If you have those 4 things, then what we can do with those 4 things is we can shortcut some of our probabilities that we've been doing. These are just some symbols. P of S is the symbol of success, and a lot of books use P for probability, and some books use Q for failure. And that's what I'm going to be using just because I'm kind of used to it. So the probability of success is P, the probability of failure is Q. These are always complements because we've reduced it to 2 outcomes. So the probability of success, if 1 is 40, this is 60, this is 70, this is 30. N is going to represent the number of trials or the number of times that we do it, and X is going to represent how many successes we want out of the number of times we do that. Okay, so this would be like 20 free throws, and I want the probability of making 14 of them. That would be your X. Other books don't use the Q, they just use the 1 minus P. That's what AP uses, but a lot of books use the P and Q. Okay, so let's talk about the binomial formula. You're going to see the binomial formula written several different ways. I kind of change it up here. So the first thing that we're going to talk about is this part right here. This is the change up. Okay, so if you're taking AP, this is going to be N and an X here. And it's just kind of a symbol that AP uses and also the SEC book uses. Then you're going to take it, probability of successes, how many you want, probability of failure, and how many you want. Okay, so this is your success. This is your failure. This is number of failures. This is number of successes. And you'll see it a little more clear when we go through it and do a problem, and I'll explain the probability. This is just kind of a symbol that we use. This is your total. And then remember, X, that's your total number of trials, and X, once again, is your number of successes. All right, so also you will sometimes see this written, the formula, I'm going to go up here because I ran out of space, as NCX, and then the probability of this stays the same. Success, how many? Failure, how many? These are complements of each other, and so this is going to always add up to your total. This is going to be your successes, your failures, and N is your total. Right, so we're going to write it, to do it on the calculator without this function that I'm going to show you. You use this right here, but I'm going to show you a function that does all this really quickly on the calculator. Okay, so calculator functions, you're going to go to second vars, and it's these two functions. I didn't put a number on it, but one is a Binom Pdf, so be careful, and one is a Binom Cdf. You always need to do either the formula, or when you're doing it in the calculator, you need to know three things: N, P, X. You need to know the number that you have, the probability of the success, and how many you want. And these little brackets, I'll show you where those are too when we get to it. All right, so there's two different functions we're going to use, and I'll get into that once we start the calculator functions. I just want to have that written down for you. Okay, so let's talk about a coin toss. So what this whole section is about is making your life easier. So previously we did a coin toss, and we had to, in order to find the number of heads, we had to do heads, tails, that's one coin toss, heads, tails, that's two coin tosses, and then heads, tails, tails, heads, tails, heads, tails. All right, so then we have, for the outcomes, heads, 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 tails, heads, tails, heads. I'm just going through the branches. Heads, tails, 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 heads, heads, tails, heads, tails, 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 heads. And last but not least, tails, tails, tails. So for tossing three coins, you have, I did that really fast, you have 8 total outcomes. So that's just for 3 coins. So imagine if you have 10 coins, that's going to be 2 to the 10th power. You don't have time to do a tree diagram for all of these probabilities. All right, so let's make a probability distribution, and I'll show you where this binomial stuff comes in handy. All right, so I can toss a coin and get heads 0, 1, 2, 3 times. The probability of each, there's 8 outcomes. And then I go through. How many 0 heads? 1. How many with 3 heads? 1. And then if you go through these combinations, there is, I'll do this one, 1, 2, 3 that have 1 head and 2 tails. So then there's also 3 of these, and we have done those in previous lessons. All right, so what today's lesson is about is to show you how to shortcut this so you don't have to do this anymore. We don't have to do this anymore, and a quick way to get these probabilities. All right, so that's what binomial does. Also, later in the lesson, instead of having to put this in list 1 and list 2 to find the mean and standard deviation, we have a really quick formula for showing you the mean and standard deviation also. So binomial is not new, it's just a shortcut of the old stuff that we've been doing. So on this problem, I have the 3 things you always must know is N, 3 coin tosses, P, the probability for heads is 0.5, and X, we want all 3 of them. So I want 0, 1, 2, 3. Oops. I want all 4 of those X's. So I want from 0, 1, 2, and 3. All right, so I'm going to show you on the calculator. I'm going to go through the problems with you, but I want to show you where we're going with this. So if you don't do your calculator right now, just kind of pay attention to me and let me show you where I can quickly get all of these probabilities without doing this. All right, so don't pick up your calculator. Oops, sorry. Don't pick up your calculator yet. All right, so I'm going to go to second vars, and I'm going to go all the way down to this function called Binomial Pdf. All right, so, and then I'm going to go into enter. And they were asking me the question, number of trials, 3. I tossed 3 coins. And then the probability of those trials, each head is 0.5. And then the X value. So if you look above your parenthesis, you'll see this bracket. That's where we're going to put all of our X's in that bracket because I have more than one. So I'm going to use 0. And then here's your comma above the 7. That's kind of a new thing. Comma 1, comma 2, comma 3. And then I'm going to end the bracket. Like I said, don't do this yet. Just kind of pay attention to what I'm doing. So what I did is I said, I'm going to toss the coin 3 times. The probability of each head, each time I do a trial, is 0.5. And these are the X's that I want. Okay, so if you have an 84 or a newer 84, this is what it looks like when it shows up. If you have an older 84 and 83, then you're going to have to hand type this in. So, excuse me. So, if you have an old 83, what's going to come up is this Binom Pdf in a parenthesis. You're going to have to put in N, comma, P, comma, X. You're going to have to hand type it in that way. It's not that big of a deal, but that's where it pastes it into the function on the new 84s. Okay, now I'm going to also do something else so that you can see where I'm getting these answers. I'm going to take my answers and do math frac. And because I want my answers to be written in a fraction, so you can see the relationship between the two. So if I do math frac, what it's going to do is change my answers all to fractions. What this is going to do, this function, is it's going to find the probability for each and every one of these. I'm going to get 4 answers. And what it's going to give me the answers for every single one of these probabilities. So if I hit enter, you see 1/8, 3/8, 3/8, 1/8. So what that just did for us, okay, what that just did, oh, sorry. Why is it not going up? Sorry, I don't know what that was about. Okay, so here's what it just did. It just found by one calculator function, and me learning that calculator function, it just replaced all that. So in like a minute or less, I can get this whole probability distribution without doing all of this. That's what's nice about the binomial formula. What do you need to know to get this then? N, P, and what your X's are. So that's where we're going with this. That's what the binomial does. It seems a little difficult at first, but it really does save you a lot of time. Alrighty, example number 2. Student randomly guesses at 5 multiple choice questions. Find the probability that the student gets exactly 3 right. All right, so let's decide if this is a binomial experiment first. So, is it a BINS? Well, it's multiple choice questions and there's more than one answer, but I can do, they either get it right or they get it wrong. So I can do correct or not correct. So that can make it binomial. If you're guessing, is each question independent? Yes. Do I know how many times I'm going to do it? Yes. There's 5 questions. And is the probability of guessing going to stay the same each time? Yes. All right, so over on the side, I always write N, P, X. Why? Because I need it to write the formula and I need it to do the calculator function. So we have 5 multiple choice questions. The probability that the student gets exactly 3 right, that's how many I want right, that's my X. And each question has 5 choices. So let's say I have no clue how to do this and I want just going to guess. So I have a 1 in 5 chance, and I'm going to just change it to a decimal, a 0.2 chance of getting the question right. All right, so with binomial, you are required to know how to do 2 things. Write the number in the formula, and then after you write the number in the formula, you will also have to know how to do the function. So each question on these binomial has 2 different skills, putting the numbers in the formula and writing it down, which you will be required to do. So let's go start again. I messed up, sorry. All right, so we have 5 things and I want, actually let me clean up all this mess. I made a mistake, so I edited that video out. So here we go. We're starting over again. All right, so here we go. So I have 5 things, and I'm choosing 3 to be right. So I want 3 right. So that says I have 5 questions and I'm choosing 3. Then probability of being right is 0.2. I'm totally guessing. It has 5 choices. I'm totally guessing. So if this is the probability of being right, this is the probability of being wrong. These always will add up to 1. It's either right or wrong. Now, how many do I want right? 3. If I want 3 right and there's 5 of them, then I want 2 wrong. Okay, let me go over that formula again. I'll explain this in a minute, but let's do this part first. Probability of right, how many I want right. Probability of wrong, how many I want wrong. This will always add up to 1. These two will always add up to the total number of things you're doing. This part right here is called a combination. It's a function on your calculator, and you can write it either like this or you can write it like this. Either way, it doesn't matter how you write it. I tend to write it like this just because it's an old habit. But this is telling me I have 5 questions and I'm choosing 3 of them to be right. This gives me all the combinations of right. All right, then I'm going to go to Binom Df on my calculator, and I'm going to do it with you in a minute. I'm just going to write it down. And Binom Pdf is going to be N, P, and then X. There's only one X, so I don't need to use those brackets. That is going to give me the answer to this. All right, so we're all going to do this together. So we're going to go to second vars. So everybody get your calculators out and go to second vars, arrow down to Binom Pdf. Be careful, do not go to CDF. We'll talk about that in a minute. PDF, hit enter. And then if you have an older version, an 83 or an older version 84, just hold on a minute. So we had an N of 5, a P of 0.2, and then our X was just 3. We had 5 questions with a probability of 0.2, and we wanted to guess and get 3 right. All right, so now if you have an 83 or an 84 that's older, you're going to come up with right here, it's going to be blinking right there. So you have a parenthesis. So you're going to type in 5, comma is above the 7, n, it's always in the order of npx, 0.2, comma, above the 7, and then 3. So npx. Everybody hit enter, and that's your answer. Now that seems like it took a long time, but believe me, once you get moving with this, this is so much easier than writing out the formula and doing the formula. So 0.0512. 0.0512. So what does that mean? That means that you have approximately a 5% chance of getting 3 questions. Not a good chance of getting 3 out of 5 questions right. Out of 5, 3 out of 5 questions correct if you're totally guessing. So that's what that's saying to you. All right, let's look at the next one. All right, a survey from Teenage Research Unlimited found that 30% of teenagers consumers receive their spending money from part-time jobs. If 5 teenagers are selected at random, find the probability that 3 of them will have part-time jobs. Okay, always on the side, no matter what you're doing, your N, we're picking 5 teenagers. The probability of them having a part-time job is 0.3. We want the probability that 3 of them will have a part-time job. All right, so let's write the formula first. I'm choosing 5 teenagers. I have 5 teenagers, and I'm choosing 3 of them to have a job. The probability of them having a job, the probability of them not having a job, these always add up to 1. This is having a job. How many do I want to have a job? 3. How many don't have a job? 2. Why? Because I chose 5. These have to add up to the n, the total. These always have to add up to 1. Okay, then we're going to go to the calculator and we're going to put it in as n, p, and x again. So we go to our calculator and we hit clear, second, vars, Binom Pdf, and we have 5 teenagers, and the probability of them having a part-time job is 0.3, and we wanted 3. Okay, we hit paste, and we get that. So if you are an 83 or 84, I'm going to go over this one more time. You're going to come up with this blinking. You're going to type in 5, comma, 0.3, comma, 3. And that answer is 13.23. Okay, so there are 2 different skills that you're going to have to know for this. One is writing this formula, which you will have questions where you will just have to write the formula. That's one skill. The other skill is getting the answer. How we get the answer is on the calculator. So we do Binom Pdf for this one. I'm just showing you their calculator function. It would be 5npx. You don't need a bracket when you only have one x there. All right. Now we're going to talk about something called summation notation. If you've had pre-calc or calculus, you know what I'm talking about. If you haven't, then you're about to learn it now. Here we go. If 5 teenagers are selected, find the probability that at least 3 of them have a part-time job. So the probability is still 0.3 NPX. Okay, so at least 3 means 3 or 4 or 5. And we learned in probability that ORs mean add, so I would need to add them up. So I would have to take and find the formula for 3, plus find the formula for 4, plus find the formula for 5. So that would take, if I'm going to show work for it, that means I would have to write this formula 3 times. Well, what happens if I have 20 things and I want at least 2? That means I would have to write this formula 18 times, 19 times. Well, don't have time for that. So we're going to talk about something called summation notation. Summation notation shows you in the formula how to write this once, but represent all of these. All right, so here we go. We're going to sum up. E means to sum. That's a capital sigma. That means sum. We're going to start summing from the bottom. This is where we start at 3 and we end at 5. So this is where you start and this is where you end. This tells somebody that I'm going to start at 3 and plug x's into my formula, and I'm going to end at 5. All right, so my next part of my formula is 5. C, and then this is going to change. This is normally my x, right? Like look up here. See how this was a 3? That was my x. Well, that's going to change. First it's going to be a 3, then it's going to be a 4, then it's going to be a 5. So I do an x. The probabilities maintain the same each and every time. It's going to be 0.3 and 0.7. All right, the other thing that's going to change is up here when I did it, and it was 3. It was 3 and 2. Well, that's going to change. It'll be 3 right, 2 wrong. Then it's going to be 4 right, 1 wrong. Then it's going to be 5 right, 0 wrong. So I need to represent that using x. So sometimes my x is going to be 3, then it's going to be 4, then it's going to be 5. So that's my x there. And then this represents how many I get wrong. If I have x right and I have 5 total, that means it's 5 minus x. Okay, so this is going to be right here. This is going to be right, and this is going to be wrong. Okay, so start and end. This is your x. This is how many you want. This is going to be your right, and this is going to be wrong. Sorry, I had to turn my phone off. It was dinging at me. Okay, so now that's how you write the formula. Why do I have this E thing here? Because I have to sum. So anytime you have to sum anything, you're going to have to now see an E. So if I'm going to add things together, if I have more than one X, I need to see the summation. This is called a summation notation. This is sigma, it means the sum. Okay, now to do it in the calculator. We need an X of 3, 4, and 5. So I'm going to go to my calculator. Okay. Binomial Pdf. The trials were 5. The probability was 3. Now these X's are going to change. So we're going to go down here. And now you got to use brackets right above that parenthesis. So you're going to do second, parenthesis, and you get a bracket. And then you're going to do 3, 4, 5, and then end your bracket. All right, so the only thing that changed in this problem is that now instead of 3, it's at least 3. So I needed to, oops, I have a parenthesis and a bracket there. I need to get that out of there. Okay, so I need, in my X's need to be in these brackets. The brackets are above the parentheses. See right here and right here. All right, now I'm going to paste. So for 83 people, you're going to type in 5, comma, 0.3, comma, and then the brackets just like I did. All right, now once everybody gets that in, you're just going to hit enter. All right, there's the answers for 3. We already got that one, right? That 13.23 from the last problem. There's the answer for 4, and then there's the answer for 5. Now, it's a summation. We need to sum those up. So we learned the other day on our calculator where the sum function is. The sum function is second stat, math, number 5, enter. And I'm going to tell it to sum up my last answer. The last answer is right above the negative. See ANS? So I'm going to do second ANS and then enter. It went back and added those 3 things together. So this is the answer to 3, 4, and 5. And then I said, hey, sum up my last answer. It went to the bracket and added those nicely for me. So my answer is 16.3. So 16.3%. So that's my probability if I totally guess on a multiple choice exam of getting 3 or 4 or 5. At least 3 means 3 or 4 or 5. So I'm adding those together. All right, so to do this on the calculator, we did Binom Pdf. I'm just writing it down so you can see it. You don't have to write this part on your paper. I'm just writing it down for our note's sake. 3, 4, 5. And then after we got our answer, there was 3 answers there. We did second stat, got a sum, and then we called up our last answer, which was in the bracket. And the ANS, remember, is above the negative. All right, let's try another one. All right, public opinion reported that 5% of Americans are afraid of being alone in a house at night. If a random sample of 20 Americans is selected, find the probabilities. All right, so we've got a couple different probabilities we're going to find. We got 20 people, and we want the probability of 5%. Be careful, everybody puts 50. It's really 5%, so it's 0.5, not 0.5. I don't know why everybody makes that mistake. All right, so first question. There are exactly 5 people in the sample who are afraid of being alone at night. So 20, our X is exactly 5 on this one. This is going to stay the same because we're just doing ABC here. Okay, so 20, choose 5. 20 people, I'm choosing 5 to be afraid. The probability of being afraid, how many are going to be afraid? The probability of not being afraid, how many are not going to be afraid? These add up to 1. These add up to 20. Afraid, how many? Not afraid, how many? This tells me I'm taking 20 people and choosing 5. This gives me how many combinations of different probabilities that I have. All right, then I go to my calculator and I'm going to I'm going to write it here, binom. You don't have to write this. I'm just doing it for note's sake. Binom Pdf, n is 20, probability is 0.05, and then I want 5 to be afraid. So you're going to go to your calculator and do that, and we'll get the answer. What are you required to show? You are required to show this every single time and the answer. I am only writing this calculator function down for you so that you have it on your notes. So I go to Binom Pdf, clear, second bars. Sometimes it's faster for me to go from the bottom. And then I have 20. And then the probability of being afraid was 0.05. And then I wanted, I think, 5 to be afraid on that one. And you get an answer of 0.0022. Try to take these to 4 decimal places. I'm not sure if I did that on my last one. Okay, so 0.0022. And I'll pull that back up. Yeah, just making sure my math is right. Okay, there are now at most 3 people. At most 3 means 0, 1, 2, 3. At most 3 means 0 to 3, and it includes 3. So that means I'm going to have to do a summation function, because if I have more than one x, I need to see this e on your paper. Okay, so I'm going to start counting from 0 and go to 3. Then I have 20 people, and I'm choosing, this is going to change. These are your x's. There's not one x now like there was here. There are multiple x's. And then success, well, afraid, not afraid. I'm not sure if that's a success, but afraid and not afraid. How many do I want to be afraid? That's going to change. 0, 1, 2, 3. How many not afraid? I have 20 people, right? I have 20 people. So I'm going to have 20 minus x. See how this added up to 20 people? Because this is afraid and not afraid. So this would be afraid and not afraid. And then I'm going to show you 2 ways to do this on the calculator. The first way that we're going to do it is Binom Pdf. And I'm going to squeeze this in, and we're going to put in 20, comma, 0.05, comma, in brackets, 0, 1, 2, 3. And then we'll sum that up. And then we'll hit our sum function. I'm going to do it that way. Then I'm going to show you another function called Binom Cdf in a minute. All right, so let's do the Binom Pdf. It's just another option. Okay, so second bars. Let me clear first. Second bars. Binom Pdf. And we had 20 and 5. And now we need a bracket. And then we wanted at most 3. So 0, comma, 1, comma, 2, comma, 3. And then another bracket. All right, so 20 people being afraid, at most 3, paste. You just have to type this in if you're an 83 person. You do it in the same order that we do. And these are the answers. If you right arrow, you can see all of the answers. There are 4 of them, 0 through 3. We're going to get the calculator to sum this for us. Second, stat, sum, and call up our last answer. And it sums up those 4 for us, and we get 9841. All right, so I'm going to write my answer down. Okay, now I'm going to show you a new function. This is called Binom Cdf. It is right below the PDF. The only difference is instead of PDF, it says CDF. C stands for cumulative, and cumulative means to add. All right, so here's what I'm going to type in my calculator. I'm going to type in 20 because I have 20. Then I'm going to type in my P, so N, P, and then the X. The X in this case is 3. All right, here's what this function does. It takes this number, and it knows cumulative, and it does the probabilities for 0, 1, 2, 3, and adds them up automatically. It's a plus, sorry. So as soon as it sees this C and the 3, it does 3, 2, 1, 0, and adds them up. You're going to get this answer real quick by just typing this in. So I'm going to go to my calculator, and it's in their second bars, same place, second, oops, sorry, hit the Y equals, sorry, second bars, and I'm going to go to B, just CDF, it's right below the PDF. And then I'm going to say 20, let me do something, second bars. It didn't go into it, did it? Okay, sorry, 20, and then the probability was 0.05, and then I'm going to tell it 3. That CDF, as soon as it says a CDF and it says a 3, it does 3, 2, 1, 0, and adds it up. And you get the answer. Oops. I have a mess here. Maybe I have to type it in again. Shoot. Oh, well, you'll see it again. Binom Cdf. I don't know what I did there. Okay. It takes you straight to the answer. So look at the difference. Binom Pdf 25, 0, and 2, 3. You get the 4 answers, and then you have to sum. If you use the CDF function and tell it just 3, it does all of this for you. So it does 3, 2, 1, 0, and adds it. You get the same answer. So it's just another function that'll save you some time when you're going through and doing it. So anytime you want to go from a number all the way to 0, you can use this CDF function. You can still use the Binom Pdf, but I'm just giving you another choice. Okay, now, next one. This is where it gets really confusing here. There are at least 3 people in the sample who are afraid of being alone at night. So N is still 20. P is still 0.05. I'm just copying it from above. And we want at least 3. At least 3 includes 3. So our X is going to go from 3 all the way to 20. So 3, 4, dot, 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 all the way to 20, and I have to add that up. All right, so let's think about this. Let's write the formula first. The formula is going to look exactly like this one, except where we're starting and stopping. So I'm going to start adding at X of 3, and I'm going to go all the way to 20. That tells somebody that I plugged in 3, 4, 5, 6, 7, all the way to 20 into the formula. 20 CX, that's the same because my X is going to change. Scared, not scared. How many scareds I want? If I want X scareds, then I want 20 minus X not scared. All right, so that's the formula. That's 1 point, 1 skill here. Now let's talk about this. 2 choices. You can use Binom Pdf. And what you're going to do right here, you're going to do 20, 0.05, and then you must put in 3, 4, 5, 6, all the way to 20. You have to put all those numbers in. So that's one choice. That's going to take you a while, but that's one choice that you have. Another choice you have is thinking about that whole concept of at least ones. Let's do the complement. So in this function, what it looks like is a probability distribution. Okay, is it goes 0, 1, 2, 3, 4, 5, 6, 7, 8, all the way to 20 as a probability distribution. And each of them have their own probabilities. Okay, so that's what we found up here, right? So we found, one of the ones that we found was 5. So that was 0.0022. So that would be right here. That was the first question we found. All right, so each one of these have a probability. The second thing that we found was the sum of those. All right, now we want the probabilities from 3 all the way to 20. So we want all of these added up. That's what my question is. So let's say, and I haven't done the question yet, so let's say that this answer is 0.6. If this answer is 0.6, let's think about it as the complement, then this answer, 0, 1, and 2, would have to be 0.4. All probabilities add up to 1. So sometimes it's easier, it's kind of doing that at least one thing. Sometimes it's easier to do what you don't want and then do 1 minus it. So instead of typing 3 through 20 in, I'm going to just find the probability of 0, 1, and 2. And if that answer, let's say, is 0.4, then the answer that I want is 0.6. So that's what I'm going to do here. So I write the formula as what I want. But what I'm going to do in the calculator is I'm going to do this. There's 2 ways to do this. So to get the 0, 1, and 2, I can go Binom Pdf, and I can type in 20, 0.05, comma, and then do 0, 1, 2, and then add that up, and then sum it up, sum up my answer. That's one way to get this. Or I can use that CDF. So if I tell it to do Binom Cdf, I say 20, 0.05, and I just say 2. CDF does this for you. It'll do 2, 1, 0, and add them up. And it'll sum it. So this takes the place of all of this. Now, once I have that in blue, I'm just going to take 1 minus that answer. So I'm going to do 1 minus whatever that answer is, and then I'll get the answer I want. So what I'm doing is here, because I don't want to type in 3 through 20, don't want to type in 3 through 20, I'm going to do what I don't want. I don't want 0, 1, and 2. And then I'm going to do 3 through 20. All right, so I'm going to go to my calculator. I'm going to use the CDF function. You can use, so clear second bars. CDF gives me 20, PO, and 2. So I have 20, probability is 0.05, and I'm doing 2. So since I'm in CDF, it's going to go 2, 1, 0, and total for me. And it's much easier, and I get 9245. Okay, that is this answer right here. Remember, I was just making that up before. That's 9245. So if I want this answer, I'm going to just do 1 minus 9245. So I'm just going to go to my calculator, and I'm going to do 1 minus that 9245, and it'll give me the answer what I want, and then I can just write it here. The other choice that you can do is that you can do Binom Pdf, remember, and then sum that up yourself, and you're going to get the 9245. And I'm getting 0.0755. Okay, if you're confused by that, rewind it and watch it again. All right, I think this is my last one of this type. I know this is a long video. All right, a report from the Secretary of Health and Human Services stated that 70% of single vehicular traffic fatalities that occur at night on weekends involve an intoxicated driver. If a sample of 15 that occur at night on a weekend is selected, find the probability that exactly 12 involve an intoxicated driver. So NPX. This is an easy one. So this is just 15, choose X, which is just 12. 70 are intoxicated, 30 are not, and then we have 12 and 3. So intoxicated, how many? Not intoxicated, how many? 15 total. This is an easy one. You're just going to go to Binom. This is just a simple 1x one. So you're going to go to Binom Pdf, 15npx. So on that one, we're going to go to, it's just a simple singular one that we started out with. There's no adding. You don't need a summation. You only write the summation notation when you're summing. There is no summing on this one. It was 15, 70%, and we wanted 3 to be intoxicated. Okay, and that is e to the negative 5. So 8.29 e to the negative 5. All right. So it is written as 8.29 e to the negative 5. So I'm going to go 5 places this way. So it's 5 places. So 1, 2, 3, 4, 5, and then 3. So super, super small. Did I do that right? Let me see if I type that in right. That seems really, really small. Yep. 1573. 1570, and I want 3. Oh, that's really small. All righty. I think it is. All right. And it's so small, and I'm looking at it now because it's such a high probability of it happening that if you only had 3 out of 15 happening to, that would be really small. The probability of it being an intoxicated driver is really high. Okay, so let's try this last one. At least 6, N is 15, P is still 0.70, and then you want at least 6. So 6 is going to be 6, 7, 8, ... all the way to 15. So I'm going to do my formula first. I have 15, choose. My x's are going to change. I have to do a sum. I'm going to start at 6 and end at 15. Then 70, 30, x, and then 15, oops, minus x. All right, so let's go through this. Anytime I have more than one x, I need this e. So I'm going to start at 6 and go to 15. This is start, stop. Then 15, choose x. X is going to change each time. Success, failure, adds up to 1. Success is going to change each time. If x is success, then 15 minus x is failure. Now, I'm going to do this during the CDF thing. You have 2 choices here. You can do this as Binom Pdf or Binom Cdf. I will show you both ways. But here's my thought on this. I'm going to do what I don't want, and it's going to make my life a little bit easier. So let's say I have this probability distribution. You don't have to write this. I'm just explaining why I'm doing it this way. All the way to 15. So you have a choice. You can do the probabilities from 6 to 15 and get that answer, sum it up. That is going to mean that you're going to have to type in Binom Pdf. You're going to have to type in 6, 7, 8, 9, whatever. I'm going to do, this is what I want. So let me do that in green. This is what I want, right? Here's what I don't want. I'm going to go 0 to 5. And to do that, I'm going to do Binom Cdf. And I'm going to do 15, 0.75. that will give me this answer here. So let me do that first, and then I'll come back. So I'm going to do Binom Cdf. I should have called back the last problem. I've just done it that way. But anyway, I have 15, comma, oh, nope, thinking I'm doing the old problems, 15.7, and then 5. Right, so I'm doing 15.7 and 5. I'm going to hit enter. So this is different. This is just 11573. PDF just does that number. This one, when you type in CDF, it does that number, and it does it all the way down to 0 and adds it up for you. So it's going to do 543210 and add it up. And I get 0037. All right, so that, all of that is 0037. Now, all I have to do is take and do 1 minus, right? 1 minus that, 0037, and it gives me this green answer. So all I have to do then, and it shortcuts my work. Now your other choice, just, and that will give me 9963. So the answer to this problem is 9963. It is a lot easier to do this, because that's all I have to type in, and then do 1 minus it. So what did I do here? I did what I didn't want. I wanted 6 through 15. So do what you don't want, 5 to 0. And then I did 1 minus it. Now, if that confuses you, type in, you can also use, let me change back to green here. You can also go to get this green section, Binom Pdf. It's going to take you a little while longer, 15, comma, 0.7, comma, and then you're going to have to type in 6, comma, 7, comma, 8, comma, 9, comma, 10, comma, 11, comma, all the way. You have to type the numbers in. You can do dot, 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 all the way to 15. Bracket, and then parenthesis. That's going to take you a while to get all of those in there. And then you get errors because you don't have commas and things like that. All right, so that's binomial probability. Last thing is binomial mean and standard deviation. All right, so one of the things that we had done at the beginning of this lesson was coin tossing. That's how I opened the lesson up, with tossing heads. And I said to you, we were shortcutting to find these probabilities. And we found the probability as 1/8, 3/8, 3/8, and then 1/8. All right, so if it's binomial, you can use these two little quick shortcut formulas. That's a square root of that whole thing. Sorry, these two little short formulas. The other way to do this, which was the lesson from the other day, to find the mean of a probability distribution, we had to take, so to find that mean of x, we had to take our x's times our probabilities, multiply them together. So this was like list 1, this was list 2. We had to multiply them together, and then we added them up. That's a long way. Then the standard deviation, if you remember, to get the standard deviation, big square root in the end, you took your x's minus the mean squared times the probabilities. This is a lesson from the other day. Sum them up and then square rooted. So this is how to do it the long way. In order to do it this way, you need the entire distribution. So on a problem like this, you're going to have to calculate this entire distribution, put all of these in list 1, and then all of these are going to go in list 2. And you have to calculate them all and put them in the list. If it's binomial, then it's going to be super easy. All you have to do if it's binomial is multiply n times p. So on this coin tossing one, all I had to do is 3 coins, and the probability of heads is 0.5. On the coin tossing, I would do 3n, and then p, and then q, and then just square root. Super easy. All right, now how do you know it's a binomial mean and standard deviation instead of all this? If they only give you an n and a p, then you're using these shortcut formulas. Okay, so let's take an example of a die roll. A die roll is binomial, okay, because it has two outcomes. On this question, we want the number of 4s. You either get a 4 or you don't. So let's go through our bins. It's binomial. You either get a 4 or you don't. Each roll is independent. The probability of a 4 stays the same. And I'm going to be told how many times I'm going to do it, 360 times. So in a problem, if they ask you to find a mean and standard deviation, and all they give you is an n and a p, you want these two formulas here. So n is 360 times the probability of a 4 is 1 out of 6. That's all you have to do. Answer is 60, if I did that right. The standard deviation on this is going to be 360, 1/6, n times p times q, 5/6, and then square root. So our problem is going to be 360. I got 50 for this. I don't know if that's right. And then square root the 50. I'm doing this on my phone. Sorry. Let me do it on my graphing calculator. It's probably better. Okay, that was right. So I just wanted to check it with my graphing calculator. 7.071. All right, so that's the mean, the standard deviation. Everybody always forgets about these cute little formulas. They're super handy. On the test or on a classwork, if they only give you the n and the p and ask you to find the mean and standard deviation, then don't do all this. You can't unless you figure out the whole distribution. You're going to be using these shortcut formulas for binomial. All right, last one of the day. This is a long video. All right. A statistical bulletin published by MetLife Insurance reported that 4% of all American births results in twins. Okay, so that's the probability, 4%. If a random sample of 8,000 births is taken, find the mean, variance, and standard deviation. So n is 800. You know you're going to be using the shortcut formula because you're not given an x. You're only given these two numbers. You're not given the whole distribution. It's binomial because you have two. You either have twins or not. They're independent of each other. I gave you an n, and the success for twins mostly, it's a little iffy, but mostly stays the same, the probability of having twins or not. Because we're talking about such a large-scale population of millions of people and births each year, then we can kind of assume this is independent. So the mean, just 8,000 times 0.04, and the standard deviation, square root, n times p times q, which is not twins. All right, we're just going to calculate those two things together. So on average, you're going to have about 320. And then the standard deviation, I'm getting square root of 307.2. Type something wrong, sorry. 8,000 times 0.04 times 0.96. Sorry, I shouldn't use my phone. I should just use a graphic calculator. 17.53. There's your mean and standard deviation. That's binomial, folks. So what did we learn? We learned how to find the probabilities using the binomial formula and the calculator. You need to know how to use both. And then we found how to use summation notation when you have more than one x. And then we found the mean and standard deviation quickly by using these formulas. So how many did I want to write? 2. How many do I? No. Shoot. Let's start again. All right, sorry about that.